This question is asking which of the following statements is not true. So all of these will be true except one. So we need to go through these one by one. So the first statement says any periodic signal with a period t can be synthesized from sine or cosine waves of frequency f0 equals 1 over t and their harmonics. And that is true. Okay, we need to sort of add here plus a DC term, but the statement is nevertheless true. B, any wave containing harmonics of some fundamental frequency will repeat itself with a period of 1 over f0. So that's really almost the same statement backwards. So these are really the same statement. So any periodic signal will repeat itself with a period t equals 1 over f0. That is almost a truism, but it's saying any wave containing harmonics of some fundamental frequency will repeat itself. So basically that is true. That is what Fourier has allowed us to do. So that's the consequence of the Fourier series. So these two are basically the same sentence. Part C says if we have an odd periodic waveform with no DC component, so that tells us, if the odd bit tells us that an equals 0. The cosine coefficient is 0. No DC component tells us a0 is 0. So all that remains in our Fourier expansion is the b terms. So it's bn times sine n omega naught t. Now remember that bn itself can be written like that as an integration. So if you were to put that in there, your expression would actually look like this. And this isn't a familiar expression. We haven't seen this expression before. It's not something we're familiar with. But this bn is actually this, and that. And this bit is that bit. So it's actually true. Even though this expression is unfamiliar, it is the result of combining these two expressions together. It's simply representing or replacing that with that. Okay, so that's true. Let's look at D. In the Fourier analysis of some signal x of t, the coefficients of the cosine terms are given by this expression. So what do we mean by the coefficients of the cosine terms? The coefficients of the cosine terms, these are the a n. And the formula for a n is 2 over t times the integral of x of t times cosine n omega naught t. And omega naught you can write as 2 pi over t, that's fine. So what's going on here? there's a couple of things that are going wrong. Here we have 1 over t instead of 2 over t, so that's mistake number 1. So that's our first problem. The second problem is instead of having 2 pi over t, let me highlight that in purple, instead of having 2 pi over t, we have here 2 pi multiplied by t. So we've got two mistakes here. So it's incorrect for that and incorrect for that, just to make it really clear. And part E, any real time domain signal can be represented in the frequency domain. Now, that is true even though you might not yet appreciate that completely. So if it's a periodic signal, it can be represented using Fourier series. And if it's non-periodic, you can represent it using Fourier transform. But both of these do allow you to represent your signal in the frequency domain. Regardless of whether it's periodic or non-periodic, you can represent it in the frequency domain. It just happens that at the time of answering this, you might not yet have read about the Fourier transform. So that's the answer to this question.